Today we're going over right triangles and how to prove that those right triangles are congruent. Right triangles have special congruence formulas, theorems that we're going to go over. We are going to also go over the original 4 that we learned in chapter 6, and then we'll look at the new ones that we have for right triangles. So to review, we're going to just review kind of what a right triangle is. Here's a triangle ABC, and it's a right triangle. And angle B is the right angle in the right triangle. And because angle B is the right angle, the side opposite of angle B, which is segment AC, that's actually going to be called the hypotenuse. The hypotenuse is the segment, so in this case segment AC, that is opposite of the right angle, which in this case is angle B. And then the other two sides that are not the hypotenuse, we call those the legs. So for triangle ABC, segment AB and segment BC would be the legs. All right, let's go over the congruence postulates and theorems that we learned in chapter 6. The first one we learned was side angle side, and this is where the angle is included, and we have the two sides that are congruent. And then that proves that those two triangles are congruent. The next one that we have is angle side angle. And this one is a little different because instead of having an included angle and having the outside having the sides, we have the included side and then we have the angles on opposite parts of that side. Then we have angle, angle, side. So angle, angle, side is where the side isn't the included side, but it's the side that's opposite of those two angles. So you have to make sure that you can tell the difference between angle, side, angle, and angle, angle, side. The difference being is one is the included side and one is not the included side. And then the last one that we learned in chapter 6 is side, 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 and that's when all three corresponding sides are congruent. So let's talk about some congruence theorems that have to do just with right triangles. The first one is going to be the HL congruence theorem. HL stands for hypotenuse leg. And this is what happens when you have a hypotenuse and a leg of one right triangle is congruent to the hypotenuse and leg, corresponding leg, of another right triangle. Then that means that those two right triangles are congruent. So a picture of it would be like this. So notice how we have the hypotenuse. Those are congruent. And then we also have some legs that are congruent. So because of that, we have two right triangles that are congruent to each other. So notice that if I try to name this theorem before I learned of hypotenuse leg, I might say that this was side-side angle, which we know is not one of our ways that we can prove right triangle congruence. So we need to make sure that we identify this. This is not side-side angle, but this is hypotenuse leg, because side-side angle is one that cannot be proven. Here is another hypotenuse leg, and this just happens to be the other leg. So this is another example of hypotenuse leg. All right, the next theorem we have is the LL congruence theorem. LL stands for leg, leg, and that's with the two legs of one right triangle are congruent to the corresponding legs of the other right triangle. Then those two right triangles are congruent. An example of that would be this. So notice that the two legs are congruent to each other. And so if we were going to name this with our previous theorems, we would say, oh, this is side angle side because it's the included angle. But because it's a right triangle, instead of calling it side angle side, we're going to call it LL. Leg, leg. All right, our next theorem that we have is the HA congruence theorem. Now, HA is hypotenuse angle. So hypotenuse angle is if the hypotenuse and an acute angle of one of the right triangles is congruent to the hypotenuse and corresponding angle of another right triangle, then those two right triangles are congruent. So this would be an example. So notice that how you have the hypotenuse, then you have corresponding angles are congruent. So if I were to describe this with my previous theorems that I learned, I would say, oh, this is angle, angle, side, or side, angle, angle. But because we're dealing with a right triangle, we are going to actually call it hypotenuse angle, or HA congruence theorem. All right, our last one is going to be the leg angle congruence theorem, and that's if a leg and one of the acute angles of a right triangle are congruent to the corresponding leg and angle of another right triangle. So there's actually two LAs that you can look at. The first one is if you have a leg and the adjacent angle. So this is called the leg and adjacent. So some might say this is LA adjacent. And then you also have what's called the LA opposite, and that would be where you have this leg and then the opposite angle. So you still have LA, it's going to be leg and then opposite angle. So notice that if this was you're using previous, this would actually be angle, side, angle if we were using previous theorems. And if it was the opposite angle, this would be side, angle, angle. All right, so let's do some practice problems. We're going to make sure that you write these examples down in your notes, all 5 of them. I want you to identify which theorem justifies the congruence. Okay, so sometimes it might not, and that means you would have to say that there's not a congruence. So here's the first one. Is triangle ADC, so triangle ADC, so we're going here, 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 is it congruent to ABC? So we know that AC is reflects across itself. So because of that, that means that we have an angle, and then we have a side. So, and then we also have this other angle because they're right triangles. So because of that, because we have an angle, a side, and then we have another. So if they're right angles, then that means that we have a hypotenuse and we have an angle. So a hypotenuse angle would be our reason. Okay, so for this one, we have our right angle, we have a leg, and then we also have the hypotenuse. So we have a leg and we have a hypotenuse, which means that we have hypotenuse leg. So for this one, we have our hypotenuse, but that's all. That's all we know that's congruent. We just have the hypotenuse. So because of that, we don't have enough information. So for this one you actually have to read the triangles that you're trying to prove, because it says is XYZ, so XYZ, so is this triangle here, is it congruent to YXW, which is this triangle here? So you can almost like pull those triangles apart if you wanted to, and that means they actually share this right here, the XY, which is a leg. So we have a leg, and then we have another leg. So we have leg, leg, which means number 2, leg, leg. Okay, so for this one, we have a leg that's congruent, but notice that these two triangles have these angles are vertical, which means they are congruent. So that means we have a leg and an angle, so that's going to be number 4, leg angle. All right, that's all 5 examples. Make sure that you have everything written down and try some problems on your own.